Hi, welcome to Project Geospatial. I'm Adam Simmons at GEOINT 2022 in Denver, Colorado. And here with me, I have the honor of speaking to Asterra. James Perry and Ellie Peretz with Asterra is joining me today. How about first of all, talk a little bit about yourselves, who you are exactly, and we'll dive right into the company.
I'll let the CEO go first.
So I am the CEO. My name is Eli. I'm running Asterra since 2015. We used to be named Utilis, and recently, about a year and a half ago, we rebranded to Asterra. Utilis was founded on the merit of helping water utilities to find their leaks. So there is an issue that is called non-revenue water. Non-revenue water is the gap between what water utilities, the water that water utilities are buying or producing and what they are selling to us, to the public. This gap can be around 20, 30, and sometimes even 40%.
Wow.
Yeah, can you imagine 40% of the water get lost just next to the consumption in our streets, below the ground, through leakages. And what we did, that was our first application. We helped water utilities, and we are still helping water utilities to find those leaks under the ground using satellites that send a wavelength that penetrate the ground, identify soil moisture, differentiate the treated water from non-treated water, and provide our customers with a map of where the next breakage is going to take place. We are doing it for the last few years. Up until now, we crossed 50,000 leaks that we found around the globe. We are the most efficient leak detection technology exists. Over time, we realized that our technology can be used for so many other infrastructure areas, for example, roads, mines, highways, railroads. And now we are providing the same type of technology for different type of problems.
So how do you detect these leaks? Is that well, you know what? I'm going to take a pause there for a second.
Yeah.
How about introduce yourself, and we'll rewind a little bit.
James Perry, Executive Vice President for the Americas region. I'm managing the operations group. And just after Ellie joined, about within a year or so, I was contracted and hired to try and develop the Americas region and markets and try and find a foothold for exactly the applications that Ellie had spoken of, which is finding leaks below ground.
Excellent. So in terms of how do you find these leaks, and what kinds of sensors do you use? What kind of data do you bring in? How does that intertwine with the rest of the geospatial industry we see at the conference like this?
Yeah, so I would start by saying that right now, Asterra, other than leak detection, is doing all kinds of infrastructure failure detection. And there are so many other problems that are around the health of our planet that can be solved with Earth observation. I see Earth observation as probably the only tool that can solve those kind of problems in a large scale. Currently, the public sector, the private sector, whoever is dealing with those problems is looking bottom up from allocation to the problem rather than looking on the overall area and identifying the issues in a very large scale. Earth observation is the only way to do it. Specifically, we are using SAR, synthetic aperture radar, which is an active sensor. What SAR can do, and where other sensors cannot do, is first to operate 24/7, go through clouds, go through dark, and to some extent penetrate the ground and give us data that no other sensor can provide. Our expertise is in SAR analytic and translate the SAR data into application, into insights. Our slogan is around actionable data. Just getting data without knowing what to do with it makes no sense. And we think that being able to go downstream to the end user, understanding the problem that they need to solve, is the key for the success of our industry, the Earth observation industry. Now, James, maybe you can talk of some examples.
Numerous that we've done. At least when you think of what we honed to do, the hardest thing first was to take all soil moisture and determine based on our algorithms, patented algorithms, the difference between all moisture to know that it's a specific chemistry of drinking water. So it's an amazing feat just to do that. And really from there, we developed a foothold in that, and now we want to go into multiple other applications and sectors. So,
sounds like an excellent opportunity for a massive humanitarian effort, especially in maybe Africa.
Absolutely. We've done projects already to date as well too, working with the UN, some of the groups looking for, as an example, wells that are being used or being drilled. There was a big push in the 90s and early 2000 to build drinking wells for about $1,000 each. And they found very quickly afterwards that they weren't being used. So with the swath that we cover and our ability to observe the earth, we would be able to tell which wells were being used or not being used and provide that information, again, actionable data, so that they could go in and try and determine why they're not being used. Are they, do they need repair or maintenance? Is there a geopolitical issue that's going on for them that they're not using these wells? And that's one way we can do good for mankind.
Excellent. Now, you mentioned other use cases as well. There's tracking things like water leaks also translate to things like tracking leaks in oil pipelines as well. Is that something that you all are getting into? I mean, it seems like a natural equivalency right there.
Yeah, well, the natural equivalent or the natural growth will be not necessarily to other liquids that goes out of the pipe. It will be on all kinds of infrastructure failures that occur all around us. So the situation around the world right now is that the infrastructure that was built and developed around the 50s,
yes,
all over the world, the Western world, Europe, the US, is failing. It's aging faster than the repair cycle.
We're talking about bridges, dams, road infrastructure.
Totally.
Could be, yeah.
And the population of the world is growing. The need of use of this infrastructure is growing faster than the speed of population. And the real challenge is allocating or focusing the resources on the real areas that needs to be focused on. For example, it's unbelievable how the public sector right now handle those problems. It's like looking in the darkness for a problem that they know that exists. They know it's there. They just don't know where it goes. So imagine that you have a budget, or they have a budget to replace or repair, let us say, 0.5% of the system a year. That's a cycle of 200 years, okay? Where do you put it? If you put it blindly, based on no data, what does it mean? For us, for them, for the health of Earth. If we can get data that will direct those efforts to the right place, we did good for everybody.
So your customer baseline here for this isn't just individual business-to-business solutions. They're entire local, county, state governments, all the way up to national governments trying to figure out how to deal with their infrastructure.
Yeah, in terms of monitoring their overall operations, it's really been a very analog approach. Things really haven't changed for decades in terms of how they maintain it. And they can never get ahead of the curve, ensuring that they stay healthy in terms of overall maintenance of the system breaking down. So what we're able to do is kind of digitize that. And for infrastructure, it's really an analog to digital transformation that we're seeing right now, using synthetic aperture radar, which generates a snapshot over time. We're using it in design build phases when they are upgrading their infrastructure, and as well a cost-effective and efficient way to digitize the entire system, to go where there's problem and to leave alone where there's not a problem. And we're able to do that by penetrating subterranean views on moisture that before us were never able to be done before.
The technology is only part of the solution. The real issue is to find the problems that needs to be solved, identify the people that can describe the problem to us. We are here at GEOINT 2022. Most of the news that we hear is around new constellations, new space, more data that is coming. I didn't see much of a downstream application, coming with answers to real problems that are occurring all around us. In order to get the industry do what it's supposed to do, we, the downstream application companies, needs to go to different places and ask, what is your problem? And understand that they cannot get back to us, explaining to us how to solve it. So think of a ground engineer that deals with ground issues, looking for an effect with his own eyes. Think of those people that are driving through the road and looking for cracks in the road. Can they even think of Earth observation as a possible direction? And if they can they think of SAR as the possible direction? And if they can they think of the combination of different wavelengths to solve the issue and how exactly the analytic can work? We cannot expect them to do that. We need to come to them with a solution. And this is the role of the downstream companies in our industry.
Absolutely. So what does that look like from a downstream in terms of an actual product or service from a deliverable standpoint? What do you actually provide your customers? Is it just a simple report? Is it notifications? Is it access to API to receive notifications of when you detect certain things or where you discover failures in infrastructure? What is the output? What is that deliverable to that downstream customer?
Well, it is and can be all of those that you've mentioned, truly. And that's the advantage of what we're doing. What we do, once we analyze the imagery and we've tasked the satellite, we process that, we make that available via a password-protected website for our customers. Our customers can be municipalities, state agencies, federal agencies. We do that business direct in the Americas and as well with engineering firms, civil engineering firms that are usually contracted to be able to manage, maintain, and support that infrastructure. So we provide that in a data layer. It can be imported into any tool they need, whether it's Esri, Autodesk, and we also have our own web-based applications where they can visualize and see that information we're providing. Percents of soil moisture at various levels from low, mid to high, where a point of interest is for a leak or also wastewater as well too.
So that platform is also being used by our customers to go and identify those locations and report back to us. So another area of uniqueness that we can say that it's probably only us. The essence of our science is geophysics. That's where most of our engineers are coming from. That's the background. They understand ground, they understand remote sensing, they understand the interaction between different wavelengths and the ground in different scenarios. Now, taking that knowledge, combining with the data that we collect back from our customers, putting an AI machine on the top of it, that's the killing application. That's where you are taking the science of geophysics, putting an AI on the top of it, increasing the chance that the phenomena indeed exist, and come to the customer with a map. So at the end of the day, the map can be integrated into whatever they are using. It can be used with our map. The combination between the data as we provide it and the action that the customer is taking then can be translated into analytics. To what effect our technology, or to what extent our technology is effective compared to the other alternative that they have in solving the same problem.
Excellent. Excellent. I will say, is there any specific things that you are publicizing at this conference that you'd like to let our audience in on? What's new, brand new this year as opposed to when you started out?
Yeah, I would have to point out new products really coming for new applications. We have a product called Earthworks, and Earthworks is intending to show all soil moisture, subterranean soil moisture at various levels of percent that's used for earth and dam maintenance, levee monitoring. Rather than poking holes in levees that are 120 years old, we could provide an actionable data set that allows much more efficient performance and monitoring of levees, dams, mining industry, roads for slippage, rail for slippage. These are all applications that fall under our Earthworks soil moisture category.
Excellent. how near real time is your data feeds in terms of how quickly can you give your customers an alert?
So this is an interesting question. We are dealing with problems that exist in the ground. They've been there before. They are still there, and it needs to be detected. But it's not. I wouldn't call it a mission critical. It's not like
time sensitive, but you're detecting things that are a problem now, not necessarily a problem that is occurring.
Exactly. So if the truck hits a cable, that needs to be repaired immediately, and we cannot detect it. So it takes between a couple of days to 2 weeks. It depends on the application and depends on the data that needs to be retrieved. To provide our customers with the data, most of our customers are working on a service contract, so they are getting a renewed data going into their dashboard on a regular basis. So you can call it SaaS, but the first S is not service, it's space. So space as a service.
Excellent. Well, gentlemen, how do people get a hold of you in case they want to reach out and find more about your product services or say, hey, we are interested? How do we sign up? Where do they go to do that?
Easiest way is www.asterra.io.
Okay.
And all of our contact information, case studies, all of our applications, and what we've been doing since about 2016 to make data actionable, we'll continue to do going forward.
Awesome. And one last question before we wrap up. For both of you, what do you want to see come about in the next 1 to 5 years for the geospatial industry to massively be a game changer or help the world community out?
Well, from my perspective, I'm quite confident with the Earth observation, the Earth monitoring that's occurring right now. The world is going to change dramatically in ways that we can't even associate with what our future is going to look like. So I know that it's going to be the downstream group that are collaborating and bring data providers together to make the data actionable. And the next Google, the next Cisco, some of which are here right now, it's going to be a new generation and a new company that's using that data within 1 to 5 years like never been done before.
Wow. Yourself?
Yeah, on the upstream, we are expecting to have better due performance in terms of the supply. So the new space and private companies are going to that direction, and we see an improvement in that area, moving from the current status or the current state of supply chain, which is quite challenging for a commercial application. That's getting better, and it will get better. On the downstream, the key is, there are 2 keys for success. One is the data fusion area, putting together different wavelengths for different applications. And the other one, as I said earlier, is the ability to identify the problems that needs to be solved. And it's all around how to make this Earth more habitat and sustainable.
Excellent. Well, gentlemen, thank you for joining me. And it was a pleasure learning a lot about Asterra, and I'm sure it is for my audience as well. Everybody, thank you for joining us, tuning in.
Thank you for having us.
Absolutely. We'll talk to everybody next time.